morning to all. Today we will learn about switchgear, that is substation. So what is switchgear and what is its purpose? The assembly of equipments like transformer, relays, circuit breakers, lightning arresters and so on. All these equipments when gathered at one place for protection, controlling and switching the electrical power supply, it is known as switchgear. So why it is required? First is controlling. For example, the power which is received at substation, it is of high voltage, because for transmission we are using high voltage like 220 kV or higher than this. This is not required at our end. So this voltage or this pressure is required to be stepped down. Means the level of this voltage should be decreased. So for controlling this power supply, that is to step down this power supply, to step down this voltage, we require transformers. For these transformers, we require their protection also. We require their switching also. So for controlling, we are using transformers to step down the voltage we are receiving at the substations. Now then is the protection. As we know, transformer is very costly equipment. For its protection, we need some devices like lightning arresters to protect transformers from lightnings, or circuit breakers to trip the circuit, to open the circuit in case of faulty conditions, in case of short circuit or overloading conditions, we need circuit breakers. So this is for protection. So when all these devices are gathered at one place for controlling, protecting and switching, then it is known as the switchgear. Then is the switching. Now we need connecting and disconnecting of various circuits. So it is done by using isolators. So this is all about the definition of switchgear and why it is required. So it is the assembly of the equipments like transformers, lightning arresters, circuit breakers, relays, isolators and many others at one place. Then is switch, isolator and circuit breaker. Switch, as we know, it is just to make or break the circuit. It is just to make the on or off of the device. Then is the isolator. Isolator is also a switch, but the difference is that isolator operates only on no load conditions, just to isolate some part. If we want to isolate some section, for example, the isolators are connected on both the sides of the circuit breaker. When there is the maintenance work required on circuit breakers, we have to open both the isolators which are connected on both the sides of the circuit breaker. So it should be operated only on no load conditions. So it also makes or breaks the circuit only for isolation purposes, but only under no load conditions. Then is the circuit breaker. So circuit breaker, obviously it is for the protection. It is a protecting device. It is for protection. So it can operate under load conditions, under no load conditions, or and its basic function is under faulty conditions. So whenever the fault is detected by relays, then the circuit breaker will open its contacts. So this is the definition of switch, isolator and circuit breakers. So this is the isolator. Two are the fixed contacts on the sides and one is the moving contact. Whenever there is the need of any isolation of any section at substation, it needs to be operated, but only under no load conditions. So here's the difference between switch, isolator and circuit breaker. Switch, as we know, it is only for making or breaking the circuit under no load or loaded conditions. Isolator, it can make or break the circuit only under no load conditions. And circuit breaker, it can make or break the circuit under no load, loady or faulty conditions. So then switch is operated manually. Isolator is also operated manually. Circuit breaker can be used as a switch. It can be operated manually or automatically. It will work under faulty conditions. Then switch, no quenching medium is required in case of switch. In isolators also no quenching medium is required because isolators are operated under low load conditions. So we don't require any quenching medium or arc extinction medium because there is no arc developed between the contacts when we open its contacts. So no quenching medium is required. But in case of circuit breaker, as the circuit breakers are operated under faulty conditions or loaded conditions, so there is a heavy arc between the contacts. In case of miniature circuit breaker, the arc is very small. So the only arc shoots are required, means it's the natural medium or just the lengthening of arc is done in that case in case of MCB that we are using at homes. But in case of circuit breakers that we are using at substations, large amount of arc because the contacts are opened at very high voltage, so there is a arc between those contacts which cannot be quenched, which cannot be extinguished naturally or by just lengthening of the arc. We cannot extinguish it, so we need some medium like oil. So on the basis of this quenching medium, the name of the circuit breaker is there. Like for if we are using oil as a quenching medium, then it is oil circuit breaker. If we are using air, then it is air circuit breaker. If we are using vacuum, then it is vacuum circuit breaker. And if we are using SF6 gas, because its dielectric strength is very good, if we are using SF6 gas, then it is SF6 circuit breaker. So in case of circuit breaker, the quenching medium is required to extinguish that arc which develops between the contacts when they are opened.